If you're any involved in math, you probably know that the sum of k first integers starting from 1 is represented by this weird formula n plus or n times n plus 1 divided by 2. But why is that? Like, who came up with this? Where did it come from? What is going on? I recently learned how it was done. I thought it was a pretty cool trick, so I want to share it. But first, I also think it's important to just show that it does work. So pick a number, let's say k1, the smallest we can pick. Okay, so let's say n equals 1. Then what this means, if you're not familiar, is the sum of k integers starting from 1 to n. So we're going from 1 to n, so there's only the 1. So what this says is that the sum of 1 should essentially be 1. Okay, that's pretty intuitive. And indeed we see this is 2, this is 2, this becomes 1. And we can actually go further and prove this is the case if you're familiar with induction at all. So for our base case, we already know n plus 1 is true. For our induction hypothesis, let's assume, yeah, some n above 1 holds. So that for any k, that this does hold, and it does work. Okay, so let's write in green. We know this works. We know this works. And now we can go even a step further and consider, so the n we had before works. Now let's do n plus 1. Okay, so this really covers all bases if this works, because if you think about it, we know the first number works, so it's just a little test. Now if n numbers work, well, this n could be anything. Choose a randomly infinitely large number that you think is the biggest natural number and do plus 1. Okay, there is no biggest natural number. Try it yourself with any number. So consider n plus 1. Then we do the sum of n plus 1 of k plus n plus 1, which becomes, here, let's write it down there. Let's make it a little smaller actually. Plus, well, we see that our k, we already know what this equals. It's the formula itself. So n times n plus 1 divided by 2, and now plus the sum of n plus 1. So we can write this as n plus 1. And we can factor out the n plus 1. Let's do square brackets. I like to do that. So n divided by 2 plus 1. This becomes, let's write plus 1. This is on 1 times 2, or only times 2 here. So n plus 2 divided by 2. And now this does sort of resemble the original equation we had. If you compare this, and look at this, you'll see all that we did was change our two little things up here, and what we did was we added 1. Okay, so n+1 does hold. So we know that it holds for all numbers, but why does it exist? I never answered that. Let me show you. This is called Gauss's pairing trick. Gauss's? I don't know. I don't know how to pronounce that. I probably offended some one guy out there. Okay, anyway. So what Gauss said is, well, we know that the sum of k integers is n times n+1 divided by 2, as we just shown. And so let's say some variable s is equal to the sum, such that s is also equal to the sum. This is just another way of writing it, of n. Now, intuitively, the sum of the first integers is the sum of the first integers. So your first integer 1 plus 2 plus 3 plus 4, and this goes on and on and on and on and on and on and on, and on until k. Okay. Or really, we should do, yeah. And so what Gauss did is he took this, right? And he just wrote it backwards. Okay, well, what does this do? So you got k plus all of the integers. So this is the, the integer we chose to count until, and this is 1 because it's our smallest. And this is mathematically fine because the order in additions doesn't matter. It's the same result. It's our n times n+1 divided by 2. And so what you can do is, well, why can't we just do, here, I'll do it in a different color. We'll consider both sums added together, okay? And what this would mean is, I mean, in theory, just 2 times the sum, but the way we write it is very unique, and you'll see why. So we were considering doing n+n, and we know s is all of our sums written out. So the 1 plus the 2 plus the 3, and let's say this is s+1, or s1. This is n, and s, and the second sum, which is still the sum, it's just a different way of writing it, is our k plus all of the other integers. Well, you can write this as your 1. Really, here's a better way of thinking about it. Instead of saying just k, let's fit k minus 1 into there, just so you get a better idea. So 1 plus 2 plus 3, it could be any number. I'm just doing the first couple, plus k minus 1, so the number just below what we're counting until, plus k minus 1 plus da 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 plus 1. And so let's just do from left to right. So we got 1 plus k, and let's sort of space it out, 2 plus k minus 1 plus 3, and our next lowest number here would be k minus 2, so k minus 2, and you sort of see a pattern, and it's that the number here is one smaller than the one you're adding to it. There's technically still a number here, it'd be 0 plus 0, and what this does for us is, well, both of our sums really just equal, well, if you add this, this is k plus 1. If you look at this, minus 1 plus 2 is also k plus 1, and 3 minus 2 is also k plus 1, okay? So both sums added together is just however many things we're counting until, 1, 2, 3, until k. So it's k many factors, or n, times our, actually it's better to write this as n. So times n. Actually, no, try not to confuse anybody. Let's just keep going as k. K plus 1. And now, if we sort of visualize it easier, we can say that two sums added together is obviously 2 times the sum. So 2 times the sum is k times k plus 1. We divide it by 2. And look what we get. The sum is equal to k times k plus 1 divided by 2. And the k in this case is just a placeholder for n. It could be anything. It's just a variable to show that this is true. And earlier, I showed that s is the sum. It's just a variable representing the sum of k first integers. So what this means is the sum of k first integers, so s is equal to this, which is equal to this. Or now let's actually write it as n. It's really what it is. We're counting until n. Divided by 2. So there it is. Gauss's pairing trick. Hope that was cool.